Problem A4. Relativistic particles obey the mass-energy relation E square equal pc square plus mc square squared. The E is the relativistic energy of the particle, P is the relativistic momentum, m is the mass, and the c is the speed of light. A proton with mass mp and energy ep collides head-on with a photon which is massless and has energy eb. The two combine and form a new particle with mass m delta called delta. It is a one-dimensional collision that conserves both relativistic energy and relativistic momentum. Question A. Determine EP in terms of MP, M delta, and EB. You may assume that EB is small. Question B. In this case, the photon energy EB is that of the cosmic background radiation, which is an electromagnetic wave with a wavelength 1.06 millimeters. Determine the energy of the photons, writing your answer in electron volts. Question C. Assuming this value for EB, what is the energy of the proton in electron volts that will allow the above reaction? This sets an upper limit on the energy of cosmic rays. The mass of the proton is given by mpc square equal 938 megaelectron-volt, and the mass of the delta is given by m delta c square equal 1232 megaelectron-volts. On the right we have table with the following relationship may be useful in solving this problem. Solution for question A. Here we can use this invariant E square equal pc square plus mc square squared. In such problems, better to use dimensionless speed of light equal 1. In that case, velocity v we can replace by relative velocity beta, and we can rewrite this equation for proton before reaction and for delta after reaction. This is the expression for full energy of proton before reaction and after reaction. But because we have energy conservation and momentum conservation, we can write these relations. We have to add energies for proton and photon here, and we have to subtract momentum for proton and momentum for photon, which is energy for photon over c. And because c equal 1, we have this relation. Now we can insert this expression to the second equation for E delta square, and that will give us this equation. Now let's simplify it. After squaring, we have this equation. EB square cancels from both sides, and now we can subtract from this equation initial expression for proton energy, and that will give us this expression. Now we can express energy for proton and momentum for proton using these relationships for relativistic energy and relativistic momentum, and we have this expression. And after all, we have function from beta, from which we can find what is relativistic velocity for proton before collision. We have 1 plus beta over square root from 1 minus beta square, equal this expression, which is using all of these parameters which we need, m delta, mp, and eb, which we can call x. And from here we can find what is beta using x. That will be this expression. And the last point, we have to use expression for EP, which is relativistic energy. And finally we have energy of proton before collision, EP, equal this expression, where x equal this expression. So that was a solution for question A. Solution for question B. In this case, the photon energy EB is that of the cosmic background radiation, which is an electromagnetic wave with a wavelength 1.06 millimeters. Determine the energy of the photons, writing your answer in electron volts. Solution. Here we can use expression for energy of photon, which is equal to h nu, where h is Planck constant and nu is frequency. And the frequency equal speed of light over wavelength. And finally we can put numbers and get this result. That was the answer for question B. Solution for question C. Assuming this value for EB, which is this one, what is the energy of the proton in electron volts that will allow the above reaction? This sets an upper limit on the energy of cosmic rays. The mass of the proton is given by 938 megaelectron volts, and mass of the delta is given by 1232 megaelectron volts. To solve this question, we have to restore factor C in these two expressions, which will give us this expression. First, we have to count what is x for given numbers. Finally, after all calculations, we will get this formula, and the answer is 1.4 10 power 20 electron volts. This number is also called GZK bond for cosmic rays. GZK stands for Greisen, Zatsepin, Kuzmin. So that was the answer for question C.